Okay, the topic that I'm going to talk about is physics in one dimension. In one-dimensional problems, you can use any of these 5 kinematics equations in order to solve for your unknown. The xf stands for the final distance, the x0 stands for the initial distance, the vf stands for the final velocity, v0 stands for the initial velocity, the t stands for time, and also the acceleration. The a stands for acceleration. In one-dimensional problems, you should always be aware of your units. So for distance, it would be in meters, the velocity would be in meters per second, the t would be in time, and the acceleration would be in meters per second square. Here's an example on how to solve a one-dimensional problem. Okay, so suppose a boy drops a stone from a 250-meter cliff. How long does it take for the stone to reach the ground? So if you're a visual learner, you can always draw a diagram, which could help a lot. So if a boy drops a stone from a 250-meter cliff, okay, let's see. Here's the cliff. Boy drops a rock. From the problem, it gives you that the cliff is 250 meters. So from here to down here, it's 250 meters. Okay, even though the problem does not give you the initial velocity, you automatically know that the initial velocity would be 0 meters per second. The initial velocity is 0 because at this point the stone does not move at all. Therefore, the initial velocity is 0. The distance would be 250 meters because that's given, and the final distance would be 0 meters because that's where the rock's going to end up, and the rock's going to end up all the way at the bottom, which is 0 meters. So from the problem, you're looking for time. The time from which the ball drops from this point all the way to the bottom. And they also give you acceleration, which is negative 9.8 meters per second square. And to solve this, you would look at your 5 kinematics equations, which is right here. And from here, you see your givens. You see which equation has all 3 of your givens in order to solve for t. Okay, let's see. The second equation you cannot use because we do not have the final velocity. The first equation we cannot use either because the final velocity is not given. The third equation we can use because we have acceleration, we have the initial velocity, and we also have distance. Okay, let's see. Okay, so all you have to do is just plug in your givens into the equations, which would be 0 meters minus 250 meters is equal to the V initial times the t. The V initial is 0, so this will cancel out automatically. Plus 1/2 at squared. Acceleration is negative 9.8 t squared. And from here, you just cancel out stuff and multiply them out. So this would be negative 250 meters is equal to 1/2 times negative 9.8 t squared. Plug in the calculator. Negative 9.8 times 0.5, which is negative 4.9. divide by both sides. T squared is equal to -250 divided by -1.9, which is equal to 51 seconds. From here you have to cancel out the square, so you square root both sides. T is equal to square root 51. And the time is 7.1. 1 second. There you go. And to find if you want to find the final velocity, you just look at the 5 kinematics equation, and you'll see that you can use this one to find the final velocity, which is basically -9.8 times 7.1 seconds, and that will give you the final velocity.